Hello, my name is Matthew Gregg and I am representing LED Group 2. Our project was a 3D LED visualizer and it had 5 engineering requirements as laid out by the class. The system should display at least 10 unique colors, have a resolution of 5x5x7, have at least 3 pre-programmed animations, have a GUI that allows users to design at least 3 messages and animations, and the display should not flicker. We met all of the engineering requirements as required by the class. We also created 2 custom requirements. Those requirements were the ability to display and read the temperature, and the ability to take GameCube controller input and play a game. We met 1.5 of those requirements. We were able to successfully take temperature readings and display them to the cube, and we are able to take GameCube controller input correctly, but we are unable to code a game in time. And this is due to some of the major challenges we faced with this build. One, our hardware was built incredibly late, like end of week 9, early week 10, and testing was basically unable to be done. That means all the code had to be written within the last 3 or 4 days of the project, and as a result, that game could not have been coded in time. In the future, we would definitely be more on top of our hardware design and order our PCBs earlier, which would allow us to test the code theory of operation. Alright, thank you. Hello, my name is Matthew Gregg. I'm a member of LED Group 2 for the 3D LED Visualizer, and my main responsibilities for the project were the main controller block, the system GUI, and the power block, or the main power supply. For the power supply, I initially developed a linear voltage regulator circuit, which I found out was too small. It was unable to deliver the power necessary, mainly because I received the wrong parts twice. So what I ended up doing was buying a 60 watt 5 volt power supply from Amazon and a buck converter, and that's pretty much that. For the second block, I coded a simple GUI in PySimple-UI, which is a Python library, and that was not too challenging in and of itself, but creating a UI that was user friendly along with that was easy to read was pretty challenging. I had never coded a UI in Python before. The major challenge for this project was the serial protocol, mainly because it was last minute. Initially, we planned for the Raspberry Pi to control the LED matrix by itself, but that was not working, so we decided to use an Arduino Mega to do it. So I had to write some serial protocols that allows the Arduino and the Raspberry Pi to communicate. That was done in Python and C, and overall I think that my role was a success, and I have some things I would do differently, but the project was enjoyable. Thank you.
My name is Blake Woolley, and I'm a member of LED Team 2. I was in charge of the controller driver and enclosure blocks for the project. For my first block, I coded the controller driver in Python, and for my second block, I modeled the enclosure in FreeCAD. I also did other things just for the project in general, like soldering all of the wires onto the bottom of the LED matrix, and making a ton of modifications to the enclosure so it could fit our needs, which included a lot of drilling, filing, and gluing. I experienced some challenges in getting the information I needed to properly design the enclosure, as well as getting the enclosure to work as intended. I'm overall proud of my accomplishments for my first experiences using CAD software and 3D printing, but if I was going to do it again, I would have been more assertive in gathering my dimensional information, and I would have designed the enclosure to have much looser tolerances to account for the inaccuracy of the printer. Overall, I think we made a tremendous effort with very little experience between us to make something new and challenging.
My name is Austin Grabowski, and I was in charge of soldering the LED matrix, programming the temperature sensor, and designing the PCBs. For the LED matrix, to help me more uniformly solder each LED, I designed and 3D printed several guides so that I could place the LEDs into the guides and solder a column at a time. With each column, I soldered them into rows, and the rows into the entire matrix. For the temperature sensor, I went with a pre-made LM375A on a chip, and I found some pre-made libraries online to help me probe the temperature sensor and receive the ambient temperature. For the PCBs, Sharon designed the schematic for the shift registers, and I went off of Sharon's schematic to design the PCB. However, I could not fit all of the 14 required shift registers and all the other components onto the PCB. So I had to split the PCB design into 3 parts and make sure each part was identical. That way, when we ordered PCBs and received multiple copies of the one design, we could just use 3 of the PCBs to achieve the required 14 shift registers. So in theory, this PCB design is scalable.
Hello, my name is Sharon Chen, and I am one of the members from LED Group 2. My responsible role in this team are display screen of Raspberry Pi and the LED controller block. For the Raspberry Pi display screen, it simply comes with it, so I don't have to do any extra work. As for the LED controller block, I choose to use shift registers to control all the 175 LED by toggle with the cathode and the anode of each LED. I am able to light them up as I want. Although I failed to abstract the LED into 3D array, which potentially could make coding easier, but I uses the hard way, which is sent in binary bits into the shift registers and toggle through latches and clocks to light them up with little delay speed. By doing this, it sure did limit the variety of animations, but it works fine. I also hard-coded all the letters and numbers in the Arduino Mega. Overall, it reaches its requirement, and I also learned a lot from this journey. Thank you.